Hi everybody, I'm Vijay Nadkarni and today I'm going to talk to you about Istio and why you need a service mesh like Istio in your microservices architecture. Well, what is Istio? Well, while Kubernetes is great at orchestrating workloads into pods and allowing us to manage and scale them and also giving us the basic framework for networking and a DNS service as an add-on so that pods can connect with each other, it doesn't really give us more advanced features that are really essential in a microservices architecture. So it cannot by itself help us configure finer rules for network traffic management and fault tolerance. It cannot enforce encryption and authorization policies for our workloads, and it can't help us monitor our traffic between our services. Well, why do we need this? Well, let's take traffic management, for instance. Suppose that we want to introduce this new dev version of this workload B, and let's say that we want only 10%, say, of our traffic destined for this microservice to come to this dev version. Or let's say that we want only traffic with certain pre-defined headers in this request. Let's say the user equals dev header to only come to this version of the microservice, and all the rest of the other traffic should probably go to the other version of the microservice B, the production version. So that, for example, would be an example of traffic management. What about fault tolerance? Well, networks aren't entirely predictable and by nature. So we need to prepare for times when there are faults in the network. So for example, let's say this network between microservice C and microservice D is faulty. And let's say our packets aren't arriving at D, or let's say the packets are arriving late. We need to ensure that this doesn't result in cascading failures downstream. We also want to monitor our traffic, and we want to find bottlenecks in our traffic end to end, and that's observability. We also want to secure our traffic. Our workspaces, for example, may span multiple data centers. So, for example, this microservice B may be in maybe on-prem, and microservice C may be in GCP, and microservice D may be in AWS. So in this case, they span not only different data centers but also different cloud providers. Um, in that case, our network is going to be handled by devices that aren't in our control. So we need to ensure that it is encrypted between our workloads. And finally, authorization. So we need to ensure that only the users that we want to access our workloads are able to access them. For example, we only want microservice C to access D. We don't want microservice B to access D. We also don't want rogue sources or rogue users to access our workloads. And this is where an Istio service mesh can help us. Istio is probably the most popular service mesh out there. It was initially developed by teams from Google and IBM with the Envoy team at Lyft in 2017. It is one of the fastest growing open source projects with an aggressive release schedule. Well, one way to visualize a service mesh is as a layer beneath your workloads. Your workloads in Kubernetes speak would be a set of pods behind a Kubernetes service resource. Now, the service mesh would intercept your traffic, all of the network traffic between your workloads, and based on the configuration that you set for it, it would decide what to do with the traffic, where to route it, well, whether to route it anywhere at all, whether to encrypt the traffic or not, and it also provides you a way to monitor your network traffic. And the way Istio does this is really quite neat. Istio injects a container called the Istio proxy container into each of your pods in your application. It is this sidecar proxy or Istio proxy container that intercepts the traffic leaving your workload containers in its respective pod before it even leaves the node. For instance, this Istio proxy would intercept any traffic that's leaving this workload container in this pod before it even left the pod, before it even left the node that this pod is assigned to. And then it would act on that traffic. It would uh, route the traffic according to the configuration that you have set for it. And let's say it was supposed to route it to this pod right here in this workload container. Uh, when the data gets there, when the traffic gets there, the Istio proxy container in the destination pod would then take it, act on it again, and then hand it over back to the workload container in that pod. So, for example, this would be responsible for routing, for beginning TLS encryption, and so on. And this may have to terminate TLS. And these Istio proxy containers decide what to do with that data based on configuration that it receives from the Istio D, which is the Istio daemon, which is in a sense a controller for Istio. It is useful to think of Istio as having two parts, a control plane made up of Istio D and some other components to help you monitor your traffic and so on, and a data plane that actually intercepts the network traffic in your cluster and acts on it. The way Istio allows you to configure it is with custom Kubernetes resources. So just as you can define resources like deployment and persistent volume claims in YAML, Kubernetes also allows you to create custom resources. Istio uses this to define its own custom resources such as virtual services, destination rules, authorization policies, and peer authentication in YAML. Istio takes this Istio D takes this configuration that you've given it in YAML and configures and figures out how to configure individual Istio proxy containers in all of your pods and configures them. It also gets details from about the traffic and resource usage from these uh, proxies and provides browser UIs as add-ons to monitor your traffic.